Hi friends, welcome back to our YouTube channel. Today we have to discuss about parallel processing in computer architecture course, computer organization course, computer organization and architecture course. Before going to parallel processing, first of all, we have to know about serial processing and what is the disadvantage in the serial processing, how that disadvantage can be overcome in parallel processing. These are the points we have to know. In 1980s or before 1980s, whatever the computers we have to use, that computers can be called as conventional computer or a traditional computer. In these computers, we have to execute the instructions in a sequential manner or in serial fashion. That type of processing is called as serial processing or a sequential processing. How these instructions of a program can be executed in a sequential manner or in serial manner. Suppose we are taking one program. In that program, there are 5 instructions are there. First, we have to execute the instruction of 1. Once that instruction completed its execution, we have to start the execution of the second instruction. Once it is completed, then we have to start the execution of the third instruction. If it completed its execution, then we have to start the execution of the fourth instruction. If it is completed its operation, then we have to start the execution of the fifth instruction. If it is completed, then all the instructions of the program can be successfully completed. Here, while executing one instruction, we cannot start the execution of the another instruction. That means 2 instructions cannot be executed at the same time. Okay, this is the disadvantage of serial processing or a sequential processing. More than one instruction cannot be executed at the same time. Next one, once the instructions of a program are executed in a sequential manner, one after the other, then execution time of the program is also increased. Then the performance of a computer system also degraded. So these are the 3 disadvantages of serial or sequential processing. First one is execution time of the program can be increased. Then second one is 2 or more instructions cannot be executed at the same time. Third one, the performance of the system can also be degraded. Fourth one, throughput of the system is also decreased. Throughput means number of programs can be executed in 1 unit of time. Okay, these 3 are the disadvantages in sequential or serial processing. How to overcome that disadvantage? To overcome that disadvantage, we have to use a technique called parallel processing. So parallel processing is a technique that is used for executing the instructions in a concurrent fashion or in overlapped fashion for the purpose of increasing the speed up of a computer system. Okay, in parallel processing, all the instructions of a program can be executed at the same time. So 5 instructions of a program can be executed at the same time. Then the execution time of the program can also be reduced and the throughput of the system is also increased. Hence, the performance of the system is also increased. Okay, whatever the disadvantages that are occurred in serial or sequential processing, that disadvantages are overcome in parallel processing by executing the instructions in a simultaneous fashion or a concurrent fashion or all the instructions are executed at the same time. Okay, now, so there are several possibilities are there for achieving parallel processing. First one is we can take more than one ALUs. Okay, we can take more than one ALUs. Each ALU can be used for executing one instruction. For example, suppose I am taking this program. Okay, so in that first instruction we are performing addition operation. In the second instruction we are performing subtraction operation. In the third instruction we are performing multiplication operation. In the fourth instruction we are performing division operation, and fifth instruction we are performing increment operation. To perform these 5 operations, we require 5 ALUs. The first instruction operation can be allocated to the first ALU. The second instruction operation can be assigned to second ALU. The third instruction operation can be assigned to third ALU. And the fourth instruction operation can be assigned to fourth ALU, and the fifth instruction operation can be assigned to fifth ALU. All the operations of a program can be start its execution at the same time. Then we are getting the output within a less amount of time. That means because of that more than one ALU we are taking, the hardware cost of the system can also be increased. Okay, technological developments are improved day by day. So these technological developments reduce the hardware cost. Whenever the hardware cost is reduced, the pipelining, the parallel processing can be achieved in a economical feasible way. That means the parallel processing can be achieved in less cost. This is one way. Okay, what is the another way? The another way is we are taking the execution unit or our ALU that can be divided into several functional units. Okay, each and every functional unit can perform its own operation, that all the functional units are independent of each other. So, more than one operation can be executed at the same time by using multifunctional units, by dividing the ALU into different functional units. This is one way for achieving the parallel processing. We already know that a CPU or a processor mainly contains 3 parts. First one is ALU, arithmetic logic unit. Second one is control unit, and third one is processor registers. These are the mainly 3 components of the CPU or a processor. So this is ALU and this is processor register. To control all these activities, we can require one unit that is called as control unit. These are the main 3 parts of the processor. Okay. Whereas in the case of computer, it can consist of three main functional units. First one is memory unit, second one is CPU, and third one is input or output unit. These are the main three parts of a computer. Whereas in the case of CPU, what are the main three components of the CPU? First one is ALU, second one is processor registers, and third one is control unit. Okay. The ALU can also be called as execution unit. One possible way for achieving parallel processing is the execution unit or ALU can be divided into multiple number of functional units. So the ALU can be divided into 8 functional units. Okay, so these are the 8 functional units. First one is adder subtractor. This is used for performing the addition and subtraction operation on the integers. So this functional unit can perform only addition and subtraction operations. Next, this functional unit can perform only multiplication operation on the integers. This functional unit can be performed logical operations such as logical AND, logical OR, and logical NOT operations. This unit can be used for performing shifting operations, either logical shift or arithmetic shift or a circular shift. Next, this unit is used for incrementing the value by a 1. Next, this unit is used for performing addition and subtraction on the floating point numbers. This unit is used for performing floating point multiplication. This unit is used for performing division operation on the two floating point numbers. So, 8 functional units are achieved by dividing the ALU into different number of functional units. All these functional units are independent of each other. How can you say that all these functional units are independent of each other? In one unit, we are performing the multiplication operation on the integers. In the another unit, we are performing the shifting operations. So, these two units are independent of each other. In this way, all these 8 functional units are independent of each other. Okay, to perform the operation in a particular functional unit, we require operands. That operand data is stored in the processor register. So, processor registers are available in the CPU or processor. They are used for storing the operand data that is required for performing the operation. After performing the operation, whatever the result we are getting, that result is also stored in the processor register. Next one, here to memory. First, the instructions are stored in the memory. To execute that instruction, whatever the operation that is used to perform, that instruction can be sent to a particular functional unit from the memory. After performing the operation, whatever the result we are getting, that result is stored in the memory. So that here we have to use bidirectional. We are taking the instructions from the memory. We are storing the result into the memory so that to memory can contain bidirectional signal. Next one, here the processor registers provide the input data to perform a particular operation in a particular functional unit. By this direction, we are providing the data. Okay. Once all the operation is completed in all units, the result can be passed to processor registers. After that, it can be stored into the memory unit. So in this way, we are performing more than one instruction can be executed at the same time. Suppose I am taking one program. That program can contain 3 instructions. That 3 instructions can perform 3 operations. First operation is shift operation. Okay. Second operation is increment operation. And the third operation is integer multiply operation. Integer multiply operation. Okay. To perform that 3 operation, for this operation we require one operand data to perform the shift operation. To perform the increment operation, we are providing only one operand data. For performing integer multiplication, we are providing 2 numbers. Okay, here we are providing one number as input. Here we are providing one number as input. Here we are providing 2 numbers as inputs. So one operand is required for performing shift operation. One operand is required for performing increment operation. 2 operands are provided for performing integer multiplication. So that only these 3 units are working and the remaining units are in ideal mode. Okay. So integer multiply functional unit can perform the multiplication operation by taking the instructions from the memory. Okay. To perform integer multiplication, we require 2 operands. That operands can be taken from the processor register and perform the integer multiplication operation. Next, to perform the shift operation, we are taking the instruction from the memory by the shift unit. Here we are performing the shift operation. It requires one operand data. That operand data can be taken from the processor register and perform the operation, either left shift operation or a right shift operation. Next one, to perform the increment operation, we are taking the instruction from the memory and taking the operand data from the processor register and perform the increment operation. Next, once all these 3 operations are completed in these 3 functional units, whatever the result we are getting, that result can be passed to this line. This line is connected to processor registers. First, the results are stored in the processor register. After that, the results are stored into the memory. Okay. To coordinate all these activities, we are using a single control unit. A single control unit is used for controlling all the activities that are done in these 8 functional units. Okay, so control unit can provide the control signal. By using that control signal, so we are taking the instructions from the memory, we are taking the data, operand data from the processor register, performing the operation in the particular functional unit. After that, the result is stored into the processor register. After that, the result can be stored into the memory. All these activities can be monitored or are controlled by using single control unit. Okay, so in this entire diagram, one control unit is there required and processor registers are required, and one ALU can be divided into 8 functional units. One control unit, processor register and one ALU. These are the 3 main parts of the CPU. So processor with multiple functional unit. This diagram shows the processor with multiple functional units. Okay, within the processor we have to use, processor is nothing but CPU. Within the processor or our CPU, we are using mainly 3 components. First one is control unit. It can control the entire operations or our activities that can be done within the processor. Second one is processor register. They are used for storing the operand data as well as storing the result. Third one is ALU. It is used for performing arithmetic and logical and shift operations. That ALU can be divided into 8 multiple functional units. Okay, here at a time 8 operations can be executed at the same time. In this way, we are achieving parallel processing technique. At a time, we are executing 8 instructions by taking the operand data from the processor registers, by taking the instructions from the memory. Once all these operations are executed, then the result is stored in the processor registers. After that, it can be transferred to the memory. Okay, so by executing 8 instructions by using a single ALU, so all 8 instructions are executed at the same time, so that execution time is also reduced. Throughput of the system is also increased. 8 programs are executed at the same time, and performance of the system is also increased. Okay, so this is the description about processor with multiple functional units. Suppose when we are comparing the sequential processing with the parallel processing, how much amount of time can be reduced? How much amount of time can be saved by using parallel processing when compared to the serial or a sequential processing? Suppose in that program there are 5 instructions are there. To execute one instruction, we require 4 seconds time. To execute second instruction, we require 4 seconds time. To execute third instruction, we require 4 seconds. To execute fourth instruction, we require 4 seconds. To execute fifth instruction, we require 4 seconds. One instruction is successfully executed, then we have to start the second instruction. It is successfully completed, we have to start the third instruction. It is successfully completed, we have to start the fourth instruction. It is successfully completed, we have to start the fifth instruction. In serial or sequential processing, to execute one instruction, it can take 4 seconds time. Here, how many number of instructions? 5 instructions are there. For each and every instruction, how much amount of time required? That is 4 seconds. So total time is 20 seconds time required to execute 5 instructions by using serial or sequential processing. Next, how much time can be taken by using parallel processing? Here, 5 instructions are executed at the same time. Okay, then 5 instructions. All the instructions can be executed at the same time. Okay, so that within the 4 seconds, all the instructions successfully completed its execution. While instruction 1 is executed at the same time instruction 2, at the same time instruction 3, at the same time instruction 4, at the same time instruction 5 also executed, so that within the 4 seconds time all the instructions, all the 5 instructions completed its execution. So within the 4 seconds 5 instructions are completed their execution. Within the 20 seconds, 5 instructions are completed their execution in serial or sequential processing. So here, how much time better parallel processing when compared to the serial processing? So 5 times. Okay, here 20, here 4. 5 times better when we are using parallel processing when we are comparing with the serial processing. Parallel processing can take only 4 seconds to execute these 5 instructions, whereas the serial or sequential processing can take 20 seconds to execute 5 instructions. So 5 times better. Which one? So parallel processing 5 times better than serial or sequential processing. Serial or sequential processing. So that we have to use parallel processing. Serial or sequential processing in olden computers, that is traditional computers or in conventional computers. Nowadays we have to use any computer. That computer uses only parallel processing. So we are seeing the simple example. Suppose one student is there. One student can execute some programs in C language. At the same time, he can listen some music by using MP3 player. At the same time, one game is also playing in another window. Okay, 3 tasks can be executed at the same time by using a single student. First one is executing the program. That is the first task. Second task is listening the music. Third task is playing the game. These 3 tasks can be executed at the same time within a single laptop. That is called as parallel processing. More than one operation can be executed at the same time. But in olden computers, it is not possible to execute more than one operation at the same time. Okay. So in this way, parallel processing is more efficient and compared to the serial processing. So MJ Flynn is one scientist name. He can classify the computers into 4 categories. So that 4 categories are SISD, second one is SIMD, and third one is MISD, and fourth one is MIMD. These are the 4 types of computers that are categorized by MJ Flynn based on the instruction stream and data stream. What is instruction stream? The set of instructions or the sequence of instructions that are executed by the the sequence of instructions that are read from the memory constitutes an instruction stream. What is data stream? The operations that can be performed on the data stored in the processor registers can be called as data stream. Sequence of instructions read from the memory constitutes an instruction stream. Operations can be performed on the data stored in the registers constitutes an data stream. Based on the instruction stream and the data stream, MJ Flynn classifies the computers into 4 categories. First one is SISD, second one is SIMD, third one is MISD, and fourth one is MIMD. SISD means single instruction stream, single data stream. Instruction string is a single and a data string is also single. Second one is SIMD, single instruction string, multiple data streams. We are taking multiple data streams, but only single instruction string I am taking. Third one is MISD, multiple instruction string, single data stream. So instruction streams are multiple, data stream is a single. MIMD means multiple instruction stream, multiple data streams. Instruction streams are multiple and the data streams are multiple. Instruction stream is nothing but set of programs. Data stream is nothing but main memory can be divided into multiple number of modules. That is called as data stream. Okay. So this is the classification. The explanation of each and every category of computer in the next video. Okay, so in this video I am specifying how to classify these computers by MJ Flynn based on the instruction stream and data stream. SIMD is nothing but conventional or a traditional computer. SIMD means it is array processor. That is discussed in the next videos. MISD means theoretically it is okay, but practically it is not implemented. MIMD means today's whatever the computers or our laptops we have to use, that comes under MIMD category. All multi-processors or multi-computers are categorized under this MIMD category. Okay. So this is the description about parallel processing and how a single computer with a single ALU perform the execution of multiple instructions at the same time by using single control unit. So that is called as parallel processing. How sequential processing is lesser poor performance when compared to the parallel processing. That means how parallel processing is better than serial or sequential processing. How MJ Flynn classifies the computers. Okay, so this is the description about parallel processing. I hope all of you understanding this video. If you really understanding this video, please click on the like button and share this video to your friends and classmates. Please subscribe my YouTube channel, Divya Srinivasarao. After subscribing my YouTube channel, click on the bell icon to get the future updates in my YouTube channel. If you have any doubts, please put your doubts in the comment section. I will try to clarify your doubts. In the comment section, we are providing the video called as Flynn's classification. Please watch this video also. If you really like this, like my tutorials, please go to this channel and go to the playlist called Computer Organization or Computer Architecture. Thank you one and all for watching this video.